Okay, so this lesson's going to be a little bit longer than normal because this is 6 pages of notes. So, like we started in class today, we're going to take a look at if and if-else statements. So now that we understand Boolean expressions, we can use them in our programs to make decisions. Before we get started, though, I want to emphasize the use of curly brackets in our code. We will be using the curly brackets to clearly indicate what code goes with the if and what code goes with the else if used. So today we're going to start off with the if statement. An if statement is sometimes also called an if-then. If the condition is true, then something happens. It is the most basic of all control flow statements. A control flow statement breaks up the flow of execution in a program. Up to this point, we have executed lines of code starting at the top of our program and just working our way down. There are many control flow statements we will use, including if else, the switch statement, that's lesson 10, for and while loops as well. An if statement tells your program to execute a certain section of code only if a particular Boolean expression is true. So something that's not in your notes is this diagram. I just call this the if diagram form. So visually, the way this works is we're working our way down lines of code until we encounter a condition. Now, if the condition is true for an if statement, we execute some block of code inside of curly brackets. Then we continue on with the rest of the program. But if the condition is false, we head down this branch and we bypass the code in the curly brackets. But either way, we continue on with the rest of the program. Here's some sample code. I made a scanner and I say enter your age. I read the integer age from the keyboard. I store it in the variable age, and now I'm checking the condition. If age is greater than or equal to 18, we print the message, you are an adult. So if the condition is true, we execute this line of code, but if it's not, we just skip around and continue on. Now, in a condition, we can use any of these operators, greater than or equal to, less than or equal to, not, equals, and not equals. But bear in mind, these two will only work with numbers, and we'll talk more about that later. So we can check for equality of two numbers in an if statement only with a double equal sign. So a correct way to check if the age was 16 is to say if age double equals 16. We might print a message, you can drive. An incorrect way would be if we said if age equals 16. This would give you a compiling error. And this is actually an assignment statement. So we don't use assignment statements, meaning one equal sign, in an if statement. Now, in the event we have two options for a given condition, we can use something called an if-else statement instead. So an if-else diagram form works something like this. So we come to condition. If the condition is true, the answer is yes, we do this block of code. But if the condition is not true, we head along this branch where we encounter a different block of code. So we execute this block of code and then we continue on with the rest of the program. Here's some sample code. Again, we're making a scanner. We're printing a message, enter an age. We're storing it in the variable y. Ooh, I made a mistake here. Okay, I should say here, if y is greater than 17, that would mean the number is 18 to make this true. Or higher, you would say SOPLN, you are a legal adult. You should also have a curly bracket right there. Else, the other option would be then that would mean I'm less than 18, and that we would head down this branch where we would print the message, you are not a legal adult. Now, our expressions can get very complicated if we have more than two options. And that's when we use something called an if-else-if. So we use this when you need to check multiple conditions. We actually have only one if and one else, but we can have multiple else ifs. So notice how I did a little underlining here. That'll show up here. So in general, the way this works, let me see if I can make this a little bigger. So I have, if the condition is true, I execute this block of code. Else, here comes another condition. If condition 2 is true, I execute this block of code. Else, if condition 3 is true, I execute this block of code. And I can keep inserting else ifs until the very end. At the very end, I have to have a final else with no condition where I will execute some lines of code. So when I say we actually have one if and one else, but we can have multiple else ifs, here's the if, the one if, way at the bottom is the one else. Let's take a look at an example of an if-else-if. So I make my scanner and I say enter a positive integer. And we're going to store that in the variable r. So this is a series of conditions, an if and else and a couple else ifs to figure out how many digits are in our integer. So if I say if r is less than 10, I could print a message, it's a single digit number. Else, if r is less than 100 and r is greater than or equal to 10, I can print a message, it's a two-digit number. Then I can check if r is less than 1,000 and r is greater than or equal to 100. And I could print a message, it's a three-digit number. And I could keep going and going and going. But in my case, I have my opening if, a bunch of else ifs, and then my final else, and I'm just going to print a message that says it's a really big number. Now the last page of notes is equality with strings. So strings are objects. We talked about that before. We cannot use double equals or not equal in a condition to check to see if two strings are equal or not equal. Not only is this true for strings, but that string objects, it's also true for any object. If you are continuing on in the AP Computer Science course your junior year, that would make sense. That will make sense to you more then. So instead, we have to use a special method called the equals method. This method's available for all objects. I do want to take a minute to go over the method signature, and this is geared particularly towards string objects. So first of all, equals returns a Boolean. So in other words, are the strings equal, true or false? So Boolean is returned. The name of the method is equals. And we have a required parameter. The required parameter is one of the strings. So let's see how we might use this. So I have a string, name is Kim. I made a scanner queue. I print a message, enter your name. So we read from the keyboard a name and we store it in ANS, which is a string. Now notice what happens here. I say name, so I have a string name. I'm calling a method from the string class called equals, and inside of parentheses, I put the name of the other string. So I'm basically trying to see if the string name equals the string ANS. If it's true, I print the names match, else I print the names are different. If instead you tried name double equals ANS, this would give you a compiling error. So these are going to be little trick questions on the next exam in regard to when you use the dot equals method. So it's something that I have to test you on. And it'll be it'll be something that you get used to working with, and you'll make some mistakes, but that'll be okay. So hang on for 1 minute. I have something that I need to add to the notes. I'm just looking it up right now. Grace Hopper was an American computer scientist and United States Navy Rear Admiral. So that's it. Tomorrow in class, we're going to do a more extensive demo, and then we'll talk about your programming projects. Thanks.